Let's start with network devices. Okay, let's start with modem. Let's start with modem. Okay, modem, not modem, it's modem. Okay, in the name itself we have MODEM. Here MO stands for modulation. Okay, DEM stands for demodulation. That's the reason it's called modem. Okay, MODEM. MO stands for modulation, DEM stands for demodulation. Now what is modulation, what is demodulation? We don't know. First we'll discuss what is modulation. Modulation is nothing but the process of converting digital data or digital signal into analog signal. Okay, and what is demodulation? The reverse process of that, the process of converting analog signal to digital signal or digital data is called as demodulation. Why do we do that is the biggest question. Why we need to convert digital signals to analog signals? First of all, what is digital signal? First of all, what is digital signal? Okay, first of all, what is signal? Signal is something which carries data. Okay, digital signal is nothing but which carries digital data. A discrete means value by value. Okay, discrete wave carrying binary data. A discrete wave or a discrete signal carrying binary data. We cannot write wave, man. We'll write signal. A discrete signal carrying binary data. See, what is digital data? Digital data is mostly in the form of voltage signals, right? 0 1 0 1 0 1. So basically you have binary digits here, 0 1 0 1. How you will represent this? Okay, we'll cover this in physical layer, how we convert binary data to digital signal. Okay, so basically digital data is represented by binary values, right? Digital signal like this. Okay, like this. Okay, 0 1 0 1 0 1 0, 0 down 1 above, 0 down 1 above. Okay, so this is nothing but digital signal. A discrete signal carrying binary data. Okay, and this can also be optical pulses. Optical pulses will be like light on off, right? What is optical? Nothing but light. They also carry like light on off, right? They carry light in the form of that. I mean, they carry the signal in the form of that. And what is analog signals? Analog signals, a continuous wave carrying numerous data. Now this is carrying finite data. This is carrying infinite data. Okay, no data is infinite, but continuous data. Okay, multiple values of data. Okay, multiple values of data. Okay, now how this is represented? This is represented by a square wave. Okay, let me erase this. How digital signal is represented? A digital signal is represented by square waves. How analog signal is represented? These are mostly represented by sine waves. Swing. Know this, right? Okay, sine waves. Okay, shit. Okay, give me 1 second. Analog signals are represented by sine waves, actually called as sinusoidal waves, but by shortcut it's a sine wave. Okay, now here if you see, at this point it is carrying multiple datas. multiple data, okay, multiple data at any particular amount of time. Okay, this is one time period, this is the second time period, this is third time period. Okay, time period 1, time period 2, time period 3. At any time, at any particular instance of time, it's carrying numerous amount of data. Okay, but in case of digital signal, if you see, at this time it is completely 1, at this time it is completely 0. It's not like it is at some particular phase. Okay, it's not like that. Okay, now digital signal mostly travel in the medium. Which medium? I mean, in which medium most digital signal travels? Ethernet. Ethernet is the medium. Ethernet is not a medium, but Ethernet fiber cables, I mean, we have Ethernet cables, right? Ethernet cables, those carry digital signals. And optical fiber. Ethernet cables and optical fibers completely carry digital signals. Okay, now analog signals are mostly in coaxial cables, phone lines, telephone lines. Okay, because in telephone lines, when you speak something, it's not like it's not like that, right? You speak something continuously, right? So that data must be definitely in the form of analog signal. Okay, it's not like one particular data. It's like hello world. It is not like that, right? You are speaking continuously, that's the reason it should be in this form. Okay, so coaxial cables and telephone lines are the medium in which analog signals traverse. Now, what is the need of converting these to this? Okay, in older generation, for the flowing of the network, I mean for the flow of the data for the internet, older generation, they used to use telephone lines for the passage of data. Okay, now someone speaks into, someone speaks, that used to get converted into analog signal and used to go into a telephone line. In older generation, what they used to do, they used to use the same telephone lines for data transfer also. For data transfer, example, A device wants to send data to B device. Now A device is in India, B device is in USA. Okay, B device is in USA. Now what A device will do? A device will generate data in the form of bits. It will generate binary data. Now A's NIC will convert that data to electrical digital signal. A's NIC. So it will be digital signal now. Here we have digital signal. But as we know, in Ethernet it is fine that it is digital signal. But once it needs to be reached to the end device, which is in USA, that needs to travel in undersea cables. Then now it's okay. Even today we have undersea cables. Today, you know, most of the undersea cables are owned by TCS. TCS owns most of the undersea cables today. You are saying that even though wireless communication is available in today's generation, why we are still using undersea cables? Note one point, bro. Wired media is very fast when compared to wireless media, right? Wired media is very fast. You know where to go. You have only one path. Wireless media, you have complete air, radio waves. In that radio waves, how many other signals are coming? You have no idea. Okay, wired media, you have only one path, you will go in that path, you have no other path. That's the reason they are very fast, and also they are error free. See, when you talk hello world in the air, okay, at the same time if someone else talks, collides, friend person will be like, speak one by one, man, speak one by one. It's another data collision. Okay, but in wired case, one gone. Only if someone comes from the opposite, only the collision will happen. But today we have CSNA CD. Okay, or token ring. So only one will speak. It should reach to, okay, here. Now it should go undersea cables, and then it should reach USA. Now here modem will sit. This modem will convert this digital signal to analog signal. Okay, that analog signal will be then gone into undersea cables. Undersea cables are nothing but coaxial high fiber cables. Okay, coaxial fibers are meant to carry analog signals. Okay, or telephone lines, they are meant to carry analog signals. Okay, and they are very cheap when compared to this optical fibers and all. Okay, so this modem at the sender's end converts the digital signal into analog signal for transmitting to media which supports only analog signal. Okay, then when it reaches USA B device, we have one more modem sitting here. This is receiver modem. Now this will convert this analog signal to digital signal, which can then be flowing through Ethernet or optical fiber or directly to receiver's NIC. Now receiver NIC can receive this digital signal and can then convert to digital data, which can be understood by the computer system. Understood? This is the flow. Modem in today's generation is mostly placed between a LAN and internet service provider. Okay, the placement of a modem is between a local area network and an ISP. ISP is nothing but internet service provider. Airtel, Jio, BSNL. Okay, these are ISPs, and this is internet. Here we have internet. Okay, here we have ISP. ISPs are nothing but the private organization or public organizations which are actually providing you the access of internet. Now these people are the one who actually own routers, who actually own switches, who actually own the large undersea cables for data transmission. Okay, and also NICs. Leave it. These are the people who own it. Okay, here by the meaning of LAN I refer to router, broadband with a Wi-Fi connection plus your phone plus your laptop. Okay, this is a LAN. Okay, modem has two ports. One is LAN port, one is ISP port. Okay, internet service provider port or WAN port, you can say. Internet service provider, one is ISP port, one is LAN port. So when you request google.com from here, this request will go to your router. Now router will send this to modem. Okay, now as it is a digital signal here, the modem will then convert to analog signal here. ISPs, as I told, they own undersea cables, okay, for transmission of data. Now when you are requesting google.com, where is google.com? It is in USA. So then from India it needs to go undersea cables. Now it will go to ISP. ISP will then send to internet. Through internet you will find google.com server somewhere sitting at the corner of the USA, and then it will come back here. Now this will be an analog signal. This will then convert to digital signal, which will be understanding by router. Router will then send to phone or laptop. That's it. Simple. Modem has two ports, LAN port, ISP port. So basically modem is used for modulation, demodulation, converting digital data or signals to analog signals. Okay, and suppose if you want to send data, here you're using chatting application. Okay, here internet, nothing but example. Here you have WhatsApp. Okay, you are chatting from here. You convert here. Okay, I mean modem converts from digital data to binary, digital data to analog. It will come to internet. You have WhatsApp server sitting here. WhatsApp server will then forward to someone sitting in the USA, and here we have one more modem, okay, which will convert that analog signal to digital data. Then it will go to your router, I mean that person's router. That person's router, it will send it to that person's device. Finish. What are three types of modulation techniques. For knowledge, you must know. What are three types of modulation techniques? There are three techniques for modulation. ASK, FSK, okay, PSK. These are the three techniques which are used to modulate a digital signal. First one is amplitude shift keying. Second one is frequency shift keying. Okay. Third one is phase shift keying. These are three modulation techniques, okay, which are used today. Okay. Now, how are these being used? Okay. So let me come with ASK. You have digital signal here. Suppose you have 0, 1, 0, 1, 0, 1. What is amplitude shift keying? Okay. The name itself says amplitude shift. So here the sender and the receiver agree that we will use ASK. Okay. Or the sender modem and the receiver's modem. They will agree that, okay, I am using ASK. Now here modem is sitting. What modem will do? Modem will have one simple carrier wave. One simple carrier wave with some constant, with some amplitude, with some constant frequency, with some constant phase. It will have one simple carrier wave running. Simple carrier wave is nothing but which carries the data. A wave which carries the data. Okay. This will be a simple like this, like this, like this. Now what it will do? The name itself says amplitude shift. What is amplitude of a wave? The height of the wave is known as amplitude of the wave. Okay, height of the wave. This is the height. This is the height. This is the height. This is the height. Height. This is nothing but amplitude. Amplitude is nothing but height of the wave. Now, what this guy will do? Okay, it will say for 0 watt signal, I will keep some amount of height. For one signal, I'll keep more height of the wave. Okay. Now it will take this here. It will take this digital signal here. You have data here. One time period, second time period, third time period, fourth time period. Okay. 1, 2, 3, 4, 5, 6. Man. Okay. Add two more. No issues. It will say the normal wave begins like this. Okay. It goes like this. Okay. Now first 0. It says for 0 I will keep this amount of amplitude. For 1 I will keep this much. Okay. Basically keeping the frequency and phase constant. Keeping the frequency as phase constant. Modifying or shifting only the amplitude of a wave is nothing but amplitude shift keying. It is a modulation technique. Okay. Now again comes 0. It will be this much amount of. Again it comes 1. It will be this amplitude. Again it will come 0. It's like this. It's like this. And then comes normal carrier wave. Now the receiver will understand through this control flag. Okay. 0. Nothing but amplitude shift keying. Now I'll understand if it is a bigger height, it means it's 1. If it is a shorter height, it means it's 0. Fine. Frequency shift keying. If we have one signal 0, 1, 0, 1, we have model sitting here. Keeping the amplitude and phase constant, modifying only the frequency is nothing but frequency shift keying. Okay, we have one time period, second time period, third time period, fourth time period. It says the height and the phase of the wave will be constant, but if it is 0, if the unit of data is 0, I will use only 1 as a frequency for a particular time period. Number of cycles, bro. It is a 1 cycle. It is 2 cycle. Okay. It is 1 cycle. Okay. If it is 1, I will use 2 as the frequency. Understood? This is 0. This is 1. And if it is again 0, 1 as the frequency. And again 1, 2 as the frequency. Now the receiver will understand, okay, if 2 waves are coming per second, example it is 1 second. If 2 waves are coming, it will be micro nanosecond, okay, it's very fast. Example, let's assume 1 second, okay. If in 1 second there are 2 waves coming, it means the data is 1. If in 1 second only 1 wave is coming, it means the data is 0. Simple. Simple. Now, third one. What is third one? Phase shift keying. Phase shift keying. Keeping the amplitude and frequency constant. Shifting the phase of a wave. Phase of a wave is nothing but phase shift keying. What is the phase? The starting point of the wave, or starting point of a wave is known as phase. Okay. Now, how they are going to use here? We have 0, 0, 1, 1, 0, 1. Okay. Now, sudden shift of starting point is described as 1. No shift. Wait. Sudden shift is nothing but the data has changed. Many people take it differently. I'll explain you like how they take it. Sudden shift in the starting point of the wave is nothing but data has changed. If there is no shift, the data hasn't changed. Okay, if I give this example, you'll not understand. Wait. Okay, let's not assume 0, 0. Let's assume 0, 1, 0, again 0, then 1. Okay. Now, we have, we'll draw a diagram here. 1 time period, 2 time period, 3 time period, 4 time period, 5 time period. Okay, now 0. Firstly, the carrier wave will begin at normal point. Start 0. Now, data has changed, right? Data has changed now. Sudden shift. If the data has changed, then sudden shift in the transfer. Now it will not go this normal path. It will follow this path. Now again 0. Again data changed. Right? After 1 0 change, it will go again like this. Now again 0. No change in data. It will again go like this. Okay? And again change the data. Shift. That's it. Simple. Changing the starting point of the wave by keeping amplitude and frequency constant is nothing but phase shift keying. Now this is one technique. But some people are like, if the data is 1, then if the data is 1, I'll change the shift starting point. If the data is 0, I'll not change. Some people do it like this, but basically what I explained to you, that was the main thing. Okay, only if the data is shared, only then we will shift the starting point, or else we will not. That's it. Alright.